Hello. Today we're going to be talking about acceleration, and that can be found in our Physical Science Chapter 3, Section 3. So we're going to review a little bit on velocity and acceleration. Let's remember that velocity of an object, when it changes, the direction or the speed of the object, then that object is accelerating. So anytime you have a Hello, today we're going to be talking about acceleration. That can be found in our physical science textbook, section 3 of chapter 3 on page 56. So we've talked about velocity and acceleration, and we need to know that when the velocity of an object changes, the object is therefore accelerating. Remember that the velocity is both speed and direction. So if you have a change in speed or you have a change in direction, you have a change in the velocity. And if that velocity changes, then your object is accelerating. What does acceleration mean? Acceleration is a change in the rate of velocity, or a rate of change in velocity. In other words, the faster or more quickly you speed up, the greater your acceleration will be. So let's think of this example. What has greater acceleration, a bicycle pedaled by a 10-year-old or a bicycle pedaled by an Olympic athlete? Obviously, we would hopefully pick the Olympic athlete would have greater acceleration because he's speeding up faster. Okay. Here's another question. What has greater acceleration between 0 to 60 miles per hour, a Prius or a top fuel drag car? Well, hopefully the Prius in 2018, when they first came out, were popular. It was 11.2 seconds, and the top fuel drag car can hit 60 miles per hour in 1/2 of a second. 0.5 seconds. So we know that the drag car can get that speed faster. And there's a clip here, so you can watch a couple of top fuel drag cars and realize how fast those things go. It's pretty awesome. If you ever had the opportunity to see one, it's definitely worth going to. This is the type of acceleration that most of us think about, acceleration in a straight line. But there are other kinds of acceleration as well. Remember, if the velocity of an object changes, the object is accelerating, meaning if we turn a direction, if we keep our speed constant but change direction, we're changing the velocity, and therefore, if we're changing our velocity, we are accelerating. Okay? Think about the second hand on a clock. All right, let's talk about graphing a little bit. Speed time graphs and acceleration. A speed time graph, it shows the relationship between speed and time. There is no change in direction. Okay? So acceleration on these graphs is either positive, as in gaining, or negative, which means losing. So just because I'm saying acceleration, that may not be the case that I'm getting speed. I could have a negative acceleration, and that would mean I'm decelerating or losing speed. Here is a speed versus time graph. Notice we have speed on our y-axis and time on our x-axis. You notice here as this increase, this is a positive velocity, a positive acceleration. There is no acceleration here because we're maintaining a speed of 10 miles or 10 kilometers per hour, excuse me. Here we have a negative acceleration or deceleration. Again, no motion, right? Because we're at a speed of 0. Here shows acceleration and so on and so forth. Okay, so just know with speed versus time, if the speed is constant, you'll have a flat line. And otherwise, you'll have a positive or negative acceleration, and that kind of shows you what's going on with speed versus time. All right, so let's talk about calculating acceleration. All right, acceleration, again, is a change in the rate of velocity. All right, so here's a formula, is actually A equals VF. A little subset there means velocity final minus the velocity initial divided by time. So notice in the written one up here, we have a change in velocity. Well, how do we know the change in velocity? Well, we have a velocity final minus a velocity initial. And a lot of times we'll talk about velocity from a standing point of 0, like not moving, to moving. And so the velocity final of 60 miles per hour minus 0, if it starts to stop, then there's not, you don't have to worry about the minus 0. But for instance, if we were at a traveling speed of 20 miles per hour and accelerated to 40 miles per hour, that is the change in velocity of 20 meters or 20 miles per hour. Okay. Again, here are the subsets. VF is velocity final, VI, velocity initial. And remember, you can have positive acceleration or you can have negative acceleration. So if we start at 40 meters per second and we decelerated or had a negative acceleration to 20 meters per second, our value will be a negative. Okay, that's why you have to make sure you put in the VF minus VI. Okay. Remember, our formula for finding distance is this. Distance equals velocity initial multiplied by time times 1/2 acceleration times time squared. Okay? And this is how you can find the distance of an accelerating object. Okay? Not an object following at a constant speed, but an object that is accelerating. And this is actually really helpful for when you toss like a penny or a rock off a cliff edge and you count the seconds that it takes to drop. And we know that our initial velocity is 0 if we drop it. The time it takes to get down, and we know the acceleration of gravity. And we'll get to that all stuff later. So it's pretty cool. This formula can actually help out in the real world quite a bit. All right, so acceleration in 2 dimensions. What are we talking about? Well, so far we've been talking about one-dimensional acceleration. That's acceleration in a straight line. But I've also talked about how you can have acceleration that changes direction because velocity is direction and speed. So if we keep our speed constant but we change our direction, we are changing velocity, which means we're having a change in acceleration. Okay? So acceleration is any change in the velocity of an object. So can an object keep the same speed and have a different velocity? Kind of talked about all that already. So remember, velocity is speed and direction. So if, therefore, an object changes direction, its velocity changes. This means the acceleration changes as well. One of the easiest ways to see this is in circular motion. Okay? Take an object that's traveling at a constant speed in a straight line and then make it go around a fixed point. Think of a merry-go-round. It has the same constant speed, also the second hand on the clock. Okay? So what is happening to the velocity? Well, notice as you go around, the speed is maintaining a constant, but the velocity is changing because our direction is changing. We're going around in a circle. So the change of velocity is toward the center of the merry-go-round. This is perpendicular to inward acceleration. And we call this centripetal acceleration because the acceleration, okay, the change of velocity is toward the center, all right, and it's perpendicular to the inward acceleration, which is the direction that you're traveling, all right. And so that's called centripetal acceleration. Now, if it was the opposite direction, that would be centrifugal, which is like when you take a bucket and have it full of water and start swinging around in a circle. The force that pushes the bucket or the water into the bucket is the opposite of centripetal. It's centrifugal, right? Like a centrifuge. Okay. So just know centripetal acceleration is the acceleration toward the center of a circular path. You will definitely see that again on the quiz. All right. And centripetal acceleration is at right angles from the direction of motion. So just notice here we have motion is the red line, and over here we have our acceleration toward the center. All right, and that is centripetal acceleration, which is why when you're riding a merry-go-round and it goes too fast and you fall off, you get flung outward because inertia goes away from acceleration. We'll talk later on about that when we get to inertia, but it's just a little precursor to that. All right, let's talk about projectile motion. What is projectile motion? Well, projectile motion is something that's thrown or shot. Why does it always curve downward? Okay, it's the motion of a projectile. Well, Earth's gravity causes projectiles to follow a curved path. This is a combination of vertical and horizontal motion. Okay? Think of it in this way. We have a throwing versus dropping. Okay? So if I take a penny and I throw it, will it hit the floor at the same time as the penny that is dropped from the same height? And I'll do a demonstration in class the day after these notes are taken, so you guys can all kind of understand and see how that works. All right? So here's our figure over here. We have this penny or that's dropped or a ball. We drop one and we throw one at the same time. Well, which one's going to hit the floor first? Okay. Just remember that vertical and horizontal motions are independent from each other. In physics, we try to separate things apart, and we found out that a vertical motion, up and down motion, vertical, and horizontal motion, they actually are independent from each other. Okay, and we'll actually do an experiment that shows that. And that is the end of acceleration. Hopefully you got some good notes.